The short answer is that in a typical HF setup like the 80-meter band with a well-matched antenna, standard RG58 coax can safely handle 400 to 500 watts PEP on SSB or CW and about 150 to 200 watts continuous duty cycle like FT8, RTTY or AM. However, your actual power limit isn't determined by a single static number. It depends heavily on frequency, SWR, and the duty cycle of your operating mode. Here's exactly how the RG58, the 2.5mm square wire, and the inverted V geometry interact to define your system's true power handling limits. In this configuration, 2.5 square millimeter copper wire, roughly equivalent to 13 AWG, is incredibly robust. It can easily handle well over 1 to 2 kilowatt of RF power without breaking a sweat. Your power limit is entirely dictated by the RG58 coax. RG58 is a thin lossy cable with a solid or stranded center conductor and a polythene or foam dielectric. Its power handling is limited by thermal breakdown. If it gets too hot, the dielectric melts, causing a short circuit. Baseline power handling at 1:1 SWR, matched load, 3.5 MHz, 80-meter band, 800 watts continuous or 1500 watt PEP, 7 MHz, 40-meter band, 600 watt continuous or 1200 watt PEP, 14 MHz, 20-meter band, 400 watt continuous or 800 watt PEP, 28 MHz, 10-meter band, 250 watt continuous and 500 watt PEP. You can see that capacity decreases as the band goes up. But that was a theoretical maximum. When you feed a real-world inverted V dipole, those ideal baseline numbers drop due to three main factors. High SWR or standing wire ratio. An inverted V configuration naturally lowers the feed point impedance from a flat dipole 73 ohms down to roughly 50 ohms depending on the included angle of the apex, typically between 60 to 120 degrees. While this geometry gives you an excellent natural match to 50 ohms coax at resonance, moving away from your center frequency will cause the SWR to rise. When SWR increases, standing waves create voltage and current peaks along the coax line. The SWR rule of thumb. At an SWR of 2:1, your coax's power handling capability drops to roughly 70% of its rated maximum. At 3:1, it drops to 50%. Mode duty cycle, SSB voice, low duty cycle around 20%. The coax has time to cool down between speech peaks. You can safely run 400 watt PEP on HF. CW, Morse code, moderate duty cycle, around 40%. Safe up to 250 to 300 watts. Digital, FT8 or RTTY, 100% duty cycle during transmission blocks. The coax is under constant thermal stress. Limit your power to 100 to 150 watts to prevent the internal dielectric from softening. If you are running a standard layout with a good SWR under 1.5:1 on the lower HF bands, use these guidelines. FT8 RTTY data 150 watts. CW Morse 300 watts. SSB voice PEP 400 to 500 watts. High quality RG58 with a solid polyethylene core handles heat significantly better than cheap generic varieties with thin shielding or low density foam cores. If you plan on deploying a 400 watt linear amplifier and pushing it to its limits, swap the RG58 run for RG8X Mini 8 or ideally LMR240 or RG213. They fit standard connectors easily but offer a massive leap in thermal headroom and lower attenuation loss.